a Wikividi Documentaries production. Don't forget to like and subscribe. Enjoy. Nikola Tesla. Nikola Tesla was a Serbian-American inventor, electrical engineer, mechanical engineer, and futurist who is best known for his contributions to the design of the modern alternating current electricity supply system. Born and raised in the Austrian Empire, Tesla received an advanced education in engineering and physics in the 1870s and gained practical experience in the early 1880s working in telephony and at Continental Edison in the new electric power industry. He emigrated to the United States in 1884, where he would become a naturalized citizen. He worked for a short time at the Edison Machine Works in New York City before he struck out on his own. With the help of partners to finance and market his ideas, Tesla set up laboratories and companies in New York to develop a range of electrical and mechanical devices. His alternating current induction motor and related polyphase AC patents, licensed by Westinghouse Electric in 1888, earned him a considerable amount of money and became the cornerstone of the polyphase system which the company would eventually market. Attempting to develop inventions he could patent and market, Tesla conducted a range of experiments with mechanical oscillators/generators, electrical discharge tubes, and early X-ray imaging. He also built a wireless-controlled boat, one of the first ever exhibited. Tesla became well known as an inventor and would demonstrate his achievements to celebrities and wealthy patrons at his lab, and was noted for his showmanship at public lectures. Throughout the 1890s, Tesla pursued his ideas for wireless lighting and worldwide wireless electric power distribution in his high-voltage, high-frequency power experiments in New York and Colorado Springs. In 1893, he made pronouncements on the possibility of wireless communication with his devices. Tesla tried to put these ideas to practical use in his unfinished Wardenclyffe Tower project, an intercontinental wireless communication and power transmitter, but ran out of funding before he could complete it. After Wardenclyffe, Tesla experimented with a series of inventions in the 1910s and 1920s with varying degrees of success. Having spent most of his money, Tesla lived in a series of New York hotels, leaving behind unpaid bills. He died in New York City in January 1943. Tesla's work fell into relative obscurity following his death, until 1960, when the General Conference on Weights and Measures named the SI unit of magnetic flux density the Tesla in his honor. There has been a resurgence in popular interest in Tesla since the 1990s. Early years. Nikola Tesla was born an ethnic Serb in the village Smiljan, Lika County, in the Austrian Empire, on 1856. His father, Milutin Tesla, was an Eastern Orthodox priest. Tesla's mother, Dorka Tesla, whose father was also an Orthodox priest, had a talent for making home craft tools and mechanical appliances and the ability to memorize Serbian epic poems. Dorka had never received a formal education. Tesla credited his eidetic memory and creative abilities to his mother's genetics and influence. Tesla's progenitors were from Western Serbia, near Montenegro. Tesla was the fourth of 5 children. He had 3 sisters, Milka, Angelina, and Marika, and an older brother named Dane, who was killed in a horse-riding accident when Tesla was aged 5. In 1861, Tesla attended primary school in Smiljan where he studied German, arithmetic, and religion. In 1862, the Tesla family moved to the nearby Gospic, Lika where Tesla's father worked as parish priest. Nikola completed primary school, followed by middle school. In 1870, Tesla moved far north to Karlovac to attend high school at the Higher Real Gymnasium. The classes were held in German, as it was a school within the Austro-Hungarian military frontier. Tesla would later write that he became interested in demonstrations of electricity by his physics professor. Tesla noted that these demonstrations of this mysterious phenomena made him want to know more of this wonderful force. Tesla was able to perform integral calculus in his head, which prompted his teachers to believe that he was cheating. He finished a 4-year term in 3 years, graduating in 1873. In 1873, Tesla returned to Smiljan. Shortly after he arrived, he contracted cholera, was bedridden for 9 months and was near death multiple times. Tesla's father, in a moment of despair, promised to send him to the best engineering school if he recovered from the illness. In 1874, Tesla evaded conscription into the Austro-Hungarian army in Smiljan by running away southeast of Likat to Mingaj, near Grakac. There he explored the mountains wearing hunter's garb. Tesla said that this contact with nature made him stronger, both physically and mentally. He read many books while in Mingaj, and later said that Mark Twain's works had helped him to miraculously recover from his earlier illness. In 1875, Tesla enrolled at Austrian Polytechnic in Graz, Austria, on a military frontier scholarship. During his first year, Tesla never missed a lecture, earned the highest grades possible, passed 9 exams, started a Serb cultural club, and even received a letter of commendation from the dean of the technical faculty to his father, which stated, "Your son is a star of first rank." During his second year, Tesla came into conflict with Professor Poskell over the Grand Dynamo, when Tesla suggested that commutators were not necessary. Tesla claimed that he worked from 3 a.m. to 11 p.m. no Sundays or holidays accepted. He was mortified when his father made light of those hard-won honors. After his father's death in 1879, Tesla found a package of letters from his professors to his father, warning that unless he were removed from the school, Tesla would die through overwork. At the end of his second year, Tesla lost his scholarship and became addicted to gambling. During his third year, Tesla gambled away his allowance and his tuition money, later gambling back his initial losses and returning the balance to his family. Tesla said that he conquered his passion then and there, but later in the US, he was again known to play billiards. When examination time came, Tesla was unprepared and asked for an extension to study, but was denied. He did not receive grades for the last semester of the third year, and he never graduated from the university. In December 1878, Tesla left Graz and severed all relations with his family to hide the fact that he dropped out of school. His friends thought that he had drowned in the nearby Mur River. Tesla moved to Maribor, where he worked as a draftsman for 60 florins per month. He spent his spare time playing cards with local men on the streets. In March 1879, Tesla's father went to Maribor to beg his son to return home, but he refused. Nicholas suffered a nervous breakdown around the same time. On the 24th of March 1879, Tesla was returned to Gospic under police guard for not having a residence permit. On the 17th of April 1879, Milutin Tesla died at the age of 60 after contracting an unspecified illness. Some sources say that he died of a stroke. During that year, Tesla taught a large class of students in his old school in Gospic. In January 1880, 2 of Tesla's uncles put together enough money to help him leave Gospic for Prague, where he was to study. He arrived too late to enroll at Charles Ferdinand University. He had never studied Greek, a required subject, and he was illiterate in Czech, another required subject. Tesla did, however, attend lectures in philosophy at the university as an auditor, but he did not receive grades for the courses. Working at Budapest Telephone Exchange. In 1881, Tesla moved to Budapest, Hungary, to work under Tivadar Puskás at a telegraph company, the Budapest Telephone Exchange. Upon arrival, Tesla realized that the company, then under construction, was not functional, so he worked as a draftsman in the Central Telegraph Office instead. Within a few months, the Budapest Telephone Exchange became functional, and Tesla was allocated the chief electrician position. During his employment, Tesla made many improvements to the central station equipment and claimed to have perfected a telephone repeater or amplifier, which was never patented nor publicly described. Working at Edison. In 1882, Tivadar Puskás got Tesla another job in Paris with the Continental Edison Company. Tesla began working in what was then a brand new industry, installing indoor incandescent lighting citywide in the form of an electric power utility. The company had several subdivisions and Tesla worked at the Société Électrique Edison, the division in the Ivry-sur-Seine suburb of Paris in charge of installing the lighting system. There he gained a great deal of practical experience in electrical engineering. Management took notice of his advanced knowledge in engineering and physics and soon had him designing and building improved versions of generating dynamos and motors. They also sent him on to troubleshoot engineering problems at other Edison utilities being built around France and in Germany. A move to the US. In 1884, Edison manager Charles Batchelor, who had been overseeing the Paris installation, was brought back to the US to manage the Edison Machine Works, a manufacturing division situated in New York City, and asked that Tesla be brought to the US as well. In June 1884, Tesla emigrated to the United States. He began working almost immediately at the Machine Works on Manhattan's Lower East Side, an overcrowded shop with a workforce of several hundred machinists, laborers, managing staff, and 20 field engineers, struggling with the task of building the large electric utility in that city. As in Paris, Tesla was working on troubleshooting installations and improving generators. Historian W. Bernard Carlson notes Tesla may have met company founder Thomas Alva Edison only a couple of times. One of those times was noted in Tesla's autobiography where, after staying up all night repairing the damaged dynamos on the ocean liner SS Oregon, he ran into Batchelor and Edison, who made a quip about their Parisian being out all night. After Tesla told them he had been up all night fixing the Oregon, Edison commented to Batchelor that, "This is a damned good man." One of the projects given to Tesla was to develop an arc lamp-based street lighting system. Arc lighting was the most popular type of street lighting, but it required high voltages and was incompatible with the Edison low-voltage incandescent system, causing the company to lose contracts in cities that wanted street lighting as well. Tesla's designs were never put into production, possibly because of technical improvements in incandescent street lighting or because of an installation deal that Edison cut with an arc lighting company. Tesla had been working at the Machine Works for a total of 6 months when he quit. What event precipitated his leaving is unclear. It may have been over a bonus he did not receive, either for redesigning generators or for the arc lighting system that was shelved. Tesla had previous run-ins with the Edison company over unpaid bonuses he believed he had earned. In his own biography, Tesla stated the manager of the Edison Machine Works offered a $50,000 bonus to design 24 different types of standard machines, but it turned out to be a practical joke. Later versions of this story have Thomas Edison himself offering and then reneging on the deal, quipping, "Tesla, you don't understand our American humor." The size of the bonus in either story has been noted as odd since Machine Works manager Batchelor was stingy with pay and the company did not have that amount of cash on hand. Tesla's diary contains just one comment on what happened at the end of his employment, a note he scrawled across the 2 pages covering the 7th of December 1884 to the 4th of January 1885, saying, "Goodbye to the Edison Machine Works." Tesla Electric Light and Manufacturing. Soon after leaving the Edison company, Tesla was working on patenting an arc lighting system, possibly the same one he had developed at Edison. In March 1885, he met with patent attorney Lemuel W. Sorel, the same attorney used by Edison, to obtain help with submitting the patents. Sorel introduced Tesla to 2 businessmen, Robert Lane and Benjamin Vail, who agreed to finance an arc lighting manufacturing and utility company in Tesla's name, the Tesla Electric Light and Manufacturing. Tesla worked for the rest of the year obtaining the patents that included an improved DC generator, the first patents issued to Tesla in the US, and building and installing the system in Rahway, New Jersey. Tesla's new system gained notice in the technical press, which commented on its advanced features. The investors showed little interest in Tesla's ideas for new types of alternating current motors and electrical transmission equipment. After the utility was up and running in 1886, they decided that the manufacturing side of the business was too competitive and opted to simply run an electric utility. They formed a new utility company, abandoning Tesla's company and leaving the inventor penniless. Tesla even lost control of the patents he had generated, since he had assigned them to the company in exchange for stock. He had to work at various electrical repair jobs and as a ditch digger for $2 per day. Later in life, Tesla would recount that part of 1886 as a time of hardship, writing, "My high education in various branches of science, mechanics and literature seemed to me like a mockery. AC and the induction motor." In late 1886, Tesla met Alfred S. Brown, a Western Union superintendent, and New York attorney Charles F. Peck. The two men were experienced in setting up companies and promoting inventions and patents for financial gain. Based on Tesla's new ideas for electrical equipment, including a thermomagnetic motor idea, they agreed to back the inventor financially and handle his patents. Together they formed the Tesla Electric Company in April 1887, with an agreement that profits from generated patents would go 1/3 to Tesla, 1/3 to Peck and Brown, and 1/3 to fund development. They set up a laboratory for Tesla at 89 Liberty Street in Manhattan, where he worked on improving and developing new types of electric motors, generators, and other devices. In 1887, Tesla developed an induction motor that ran on alternating current, a power system format that was rapidly expanding in Europe and the United States because of its advantages in long-distance, high-voltage transmission. The motor used polyphase current, which generated a rotating magnetic field to turn the motor. This innovative electric motor, patented in May 1888, was a simple self-starting design that did not need a commutator, thus avoiding sparking and the high maintenance of constantly servicing and replacing mechanical brushes. Along with getting the motor patented, Peck and Brown arranged to get the motor publicized, starting with independent testing to verify it was a functional improvement, followed by press releases sent to technical publications for articles to run concurrent with the issue of the patent. Physicist William Arnold Anthony and Electrical World magazine editor Thomas Comerford Martin arranged for Tesla to demonstrate his AC motor on the 16th of May 1888 at the American Institute of Electrical Engineers. Engineers working for the Westinghouse Electric and Manufacturing Company reported to George Westinghouse that Tesla had a viable AC motor and related power system, something Westinghouse needed for the alternating current system he was already marketing. Westinghouse looked into getting a patent on a similar commutator-less, rotating magnetic field-based induction motor developed in 1885 and presented in a paper in March 1888 by Italian physicist Galileo Ferraris, but decided that Tesla's patent would probably control the market. In July 1888, Brown and Peck negotiated a licensing deal with George Westinghouse for Tesla's polyphase induction motor and transformer designs for $60,000 in cash and stock, and a royalty of $2.50 per AC horsepower produced by each motor. Westinghouse also hired Tesla for 1 year for the large fee of $2,000 per month to be a consultant at the Westinghouse Electric and Manufacturing Company's Pittsburgh labs. During that year, Tesla worked in Pittsburgh, helping to create an alternating current system to power the city's streetcars. He found it a frustrating period, because of conflicts with the other Westinghouse engineers over how best to implement AC power. Between them, they settled on a 60-cycle AC system that Tesla proposed, but they soon found that it would not work for streetcars. Since Tesla's induction motor could run only at a constant speed, they ended up using a DC traction motor instead. Market turmoil. Tesla's demonstration of his induction motor and Westinghouse's subsequent licensing of the patent, both in 1888, came at the time of extreme competition between electric companies. The three big firms, Westinghouse, Edison, and Thomson Houston, were trying to grow in a capital-intensive business while financially undercutting each other. There was even a war of currents propaganda campaign going on, with Edison Electric trying to claim their direct current system was better and safer than the Westinghouse alternating current system. Competing in this market meant Westinghouse would not have the cash or engineering resources to develop Tesla's motor and the related polyphase system right away. 2 years after signing the Tesla contract, Westinghouse Electric was in trouble. The near collapse of Barings Bank in London triggered the financial panic of 1890, causing investors to call in their loans to WE. The sudden cash shortage forced the company to refinance its debts. The new lenders demanded that Westinghouse cut back on what looked like excessive spending on acquisition of other companies, research, and patents, including the promoter royalty in the Tesla contract. At that point, the Tesla induction motor had been unsuccessful and was stuck in development. Westinghouse was paying a $15,000 a year guaranteed royalty even though operating examples of the motor were rare and polyphase power systems needed to run it were even rarer. In early 1891, George Westinghouse explained his financial difficulties to Tesla in stark terms, saying that, if he did not meet the demands of his lenders, he would no longer be in control of Westinghouse Electric, and Tesla would have to deal with the bankers to try to collect future royalties. The advantages of having Westinghouse continue to champion the motor probably seemed obvious to Tesla, and he agreed to release the company from the royalty payment clause in the contract. 6 years later, Westinghouse would purchase Tesla's patent for a lump sum payment of $216,000 as part of a patent sharing agreement signed with General Electric. Brought to you by Wikividi Documentaries. Would you like to know more?